In this part of the lecture, we will look at some examples of constructor overloading. And there is a case study in your book that is the time case study. You can find the complete code and explanation for this example in chapter 8 of the book in section 8.2. We will briefly go through over this example, discussing the main concepts that have been included in this example. So private instance variables hour, minute and second represent the time in a universal time format, that is the 24-hour clock format, in which hours are in the range 0 to 23 and minutes and seconds are each in the range 0 to 59. Public methods set time to universal string and toString. Class time1 does not declare a constructor, and we understand that when there is no constructor in a class, the compiler supplies a default constructor. Each instance variable implicitly receives the default int value. Since the data type of all of our instance variables is integer, the variables are private. There is a setTime method that receives 3 arguments into the parameter list, and obviously it will assign each of these values to our instance variables. Now there is a universal string to universal string method that will convert the time to the universal time format, and there is a toString method that we understand that is used for displaying the details of our objects. Instance variables and methods. The instance variables hour, minute and second are each declared as private. Private instance members are not accessible outside the class. We understand that we cannot access our private members or our private instance members from outside of the class. For example, if we try to access this hour variable using this time object that is in another class, in the test class, we won't be able to do this. Instance method, for example, in this case are two universal string and toString methods. We can access the instance methods using the object of the class, since these methods are declared as public. The codes, as you can see, are provided partially. You can go to the example in the book in section 8.2 and complete the code for this if you want to run these examples, but I will provide a brief explanation of the main points or main concepts that the example is covering. Now this is the kind of format that we want for our time, and we can set the format using the toString method, and we understand that a time is within a certain range, so we need to make sure that we are providing a valid values for our time variables, the different variables that represent the time. So the initial standard time is 12:00 AM. We understand that in the universal format this will be 0:00, since in 24-hour format the 12 AM is represented as by 00. The method setTime declares 3 int parameters and uses them to set the time. So test each argument to determine whether the value is outside the proper range. We understand that the total number of hours cannot be greater than 24. Similarly, we cannot have a time less than 0, a value for an hour or a minute or a second less than 0. We need to make sure if before assigning these values to our variables that we have valid values for these variables. For example, we cannot possibly have time with these values, that is 99, 99 and 99. If it is out of range, set the values to 0. By default, the default value is 0, so we should set the values to 0 if we do not receive a value within the range. So universal time after set time with the correct values is this one, but if it is outside of the range, then it should be converted to zeros. Case study 2, the time 2 class. As we saw that there was no constructor in our time 1 class. No constructor has been defined in time 1 class. We can only use the default one. In time 2 class, you can add 5 overloaded constructors. As you can see it in the example in the book. And overloaded constructors enable objects of a class to be initialized in different ways. To overload constructors, simply provide multiple constructor declarations with different signatures. Recall that the compiler differentiates signatures by the number of parameters, the type of the parameters, and the order of the parameter types in each signature. So the signature of a constructor will be the name of the constructor, the number of parameters that the constructor takes, and the types of the parameters as well as the order of the parameters that are within the constructor. So we can initialize different number of constructors, or we can declare different number of constructors in our classes, and we can initialize objects with different values or different number of instance variables for that class. We can also add the get hour, the get minute, and the get second methods to the time class. Also, you can add the set hour, the set minute, and the set seconds methods to the class. As I said that we will be using this as a standard for for setting the values and getting the values of our instance variables in our classes. And then we can use the toString method and the two universal string methods accordingly to set the format of our time. So once we have added the constructors, the 5 overloaded constructors that provide convenient ways to initialize objects, we can initialize objects using those constructors. The compiler invokes the appropriate constructor by matching the number, types, and order of the types of the arguments specified in the constructor call with the number, types, and order of the types of the parameters specified in each constructor declaration. So if you compare this with the example in the book, and if we look at these constructor calls, the objective 1 will be initialized with the constructor that has the default values. That is the empty constructor or maybe the default constructor that is there in the class. Object T2 will be initialized with the constructor that takes only one argument. Object T3 will be initialized with the constructor that takes two arguments, and similarly object T4 will be initialized that takes three arguments. and these will be matched at runtime. The compiler will decide which constructor uh, the is to be used to initialize a particular object. For objective 5, the constructor with 3 parameters will be used to initialize this object, but as we can see that since these values are outside of the range that we can have for our time variables, let's say the first one is for the hour, so we cannot have a value greater than 24 for our hours. Similarly, we cannot have a value greater than 60 for our minutes and for our seconds. Therefore, these will be initialized to the default values. And finally, we have a constructor that takes an object as its parameter. We'll see that we can use objects as our user-defined data types in composition in the next lecture. We can pass objects as arguments. We can use objects as variables in our other classes as well. And here, this object that initializes T6, this constructor that initializes object T6 takes another object as its parameter. And we can see that such a constructor simply initializes the object as specified in the constructor's body. Using this in method call syntax as the first statement in a constructor's body invokes another constructor of the same class. So we can use this statement in our constructors to invoke another constructor within the same class. And it is a popular way to reuse initialization code provided by another of the class's constructors rather than defining similar code in the no argument constructor's body. So if we do not want to include a code in our no argument constructor, then we can use another constructor from within the same class to initialize our values. For example, we can initialize our values to 0 using some other constructor call within this constructor. Once you declare any constructors in a class, the compiler will not provide a default constructor. We understand that once we declare a constructor in our class, there is no default constructor in that class anymore. So in this example, time2, this one is the standard constructor that takes 3 parameters. Then there are other constructors. For example, this one is with an no argument constructor. This one is a constructor that takes 1 argument. And this one is a constructor that can take 2 argument. And this one is a constructor that takes an object as an argument, that takes an object as parameter. And we can use this object to call other methods inside this constructor as well. So if you look at the example in the book, and then if you can try and complete or add all the constructors that we discuss in this example of the time2 case study. So the variables are given, and there is a set method. You can add different separate setter and getter methods for each of these variables. And then you can use maybe the set time method to call each of the method to validate the values for the instance variables. It would seem that providing set and get capabilities is essentially the same as making a class's instance variables public. that means that we are providing that we are providing access to our instance variables using the public instance methods. But as I said earlier, that we are only providing a controlled access to our instance variables through the setter and getter methods. A public instance variable can be read or written by any method that has a reference to an object that contains that variable. So if we declare our variable as public, then when we create an object for the class that has that variable, we would be able to access that public variable of the class using the object of the class. If an instance variable is declared as private, a public get method certainly allows other methods to access it, but the get method can control how the client can access it. And that is where the usefulness of the setter and getter methods comes in. That instead of providing a direct access to our instance variable, as in this case, we can use the getter and setter methods to provide a controlled access to our instance variable. A public set method can and should carefully scrutinize attempts to modify the variable's value to ensure valid values. We can only ensure that the value for a variable is valid through the setter method or maybe the constructor of the class. But if we need to change that value, we can use the set method instead of directly providing access to our instance variable. And we can perform these kinds of validations on the variable before the value is assigned to our instance variable. We can check and only modify if parameter is a valid value. Although set and get methods provide access to provide private data, it is restricted by the implementation of the methods. In simple words, the advantage of using the set and get methods is that despite that it provides access to our private instance variables to the outside to the classes from outside of our class, but that access is restricted and that is a control type kind of an access. We can perform validations and we can decide that the kind of value that we want to return using the get method, and we do not want to provide a direct access to our instance variables from outside of the class. So this can be an advantage of why we need to use the set and get methods, and this is something that we will be following in our examples and code throughout this course. In most of the cases, we will be using the set and get methods to provide access to our instance variables, and the instance variables will be declared as private. This concludes our lecture 7 over here. We'll continue our discussion of the classes and objects with some more new concepts.